In this video, we want to be able to say that I can recognize the properties of equality and identify those properties. And we also want to be able to say that I can recognize the commutative and associative property. So we want to be able to understand what these properties are. I know I've talked about it in another video for the commutative and associative. So this is going to be a little bit of review for some of you guys. Really quick, let's talk about what it means to evaluate an expression. We're in 1.3. Evaluating expression means that we are simplifying. We are trying to make it so that there's as little items in it as possible. And we want to just put things together. For an example of evaluating expressions would be like if we have 2x plus 3x, we can evaluate this. We can simplify this down to be 5x, right? We've simplified this down to be 5x. Then what we could do, if we have x equal to, let's say x was equal to 2, we can plug in 2 into that value so that this would be 5 times that 2, which equals to 10. So that was a little bit of just review of what we did last video, where we actually worked with our order of operations. Remember, we are trying to simplify it down as best we can to be able to evaluate the expression. Here's some of the properties that we're going to have. We have the reflexive property. We have the symmetric property, the transitive property, and the substitution property. Some of these properties you may have seen before. Some of them you may not have. Basically, what the reflexive property is that if we have any quantity that is equal to itself, okay? So if we have any quantity, it's going to be equal to itself. So for any real number, in symbols, we're going to say A equals A. That's a reflexive property. It equals itself. An example of this, 5 equals 5. That's an example of that. We could say 7 equals 7. That's another example of it. It equals itself. Symmetric property. If one quantity equals a second quantity, then the second quantity equals the first quantity. Woo, okay, that's a mouthful. For all real numbers A and B, if we know that A equals B, then we know that B equals A. That's what this is saying. We can reverse the order, and it means the same thing. So this one, an example of this is we can say, okay, well, x is the same thing as 5, so 5 is the same thing as x. Or we could say, another example, is that we could do, another example of what we could do is we could say 3 plus 2 equals 5. That's the same thing as saying 5 equals to 3 plus 2. We can just reverse the order. That's symmetric. That's symmetry. It doesn't matter which side of the equals it's on. It means the same thing. Okay, well, reflexive and symmetric, we're not that interesting. One that's a little bit more interesting is a transitive property. This one is a little bit more interesting in the way that it works. If one quantity equals a second quantity, and the second quantity equals a third quantity, then the first equals a third. So for all real numbers A, B, and C, if we know that A is equal to B and B is equal to C, because they both have B in them, because they're both equal to B, we can now say that A equals C. If the first equals the second equals the third, then the first is equal to the third. Okay, so here's an example of that. If we know that we have, let's say x equals to 2 plus 3, and we know that 2 plus 3 equals to y, then we automatically know that x is equal to y. I'm wanting to write 5 because that's what 2 plus 3 is. X equals to y. So if we know these two things, then we can conclude that x is equal to y because they're equal to the middle object. X equals to 2 plus 3. 2 plus 3 equals y, so x is the same as y. That's a transitive property. Substitution. Substitution, we've already done this. We've used this property actually in our other video. We've taken a value and we replace it with another value. So If we have a quantity may be substituted for its equal in any expression. If we know that A equals B, then A may replace the value of B and B may replace the value of A. So an example of this is if we have, let's say, x equals to 3. If we have the expression of, or an equation of, let's say 5x plus 1, with substitution, we can now say that this is going to end up to be 5 times 3 plus 1. Well, 5 times 3 is 15, plus 1 gives us 16. So substitution would say, okay, well, x is equal to 3 because it's the same x value. We can just take the place of the x value. We can replace it with another number. So that is substitution. Reflexive, it equals itself. Symmetric, doesn't matter which side of the equal sign it's on. Transitive, A equals B, B equals C, A is equal to C. Substitution replaces a value of. Another property that we need to make sure we know about is the identity. Identity. In math, the identity is something that we are going to end up adding, subtracting, multiplying, or dividing. We are going to take an operation, and it's not going to change what we currently have. For example, let's say we have 5 plus some number. The identity says whatever that number is, it's going to have it equal to whatever that first number was. Well, 5 plus nothing is 5. So with addition, the identity is 0. That's for addition. If we try to do multiplication, let's say we have 7. 7 times something, we need it to equal the same value. The identity of this, 7 times 1, is 7. So this right here is our identity with multiplication. The identity can change depending on your operation. Identity makes it remain the same. It does not change the value you had at the beginning. Inverse. The inverse takes you back to the identity. Okay, it takes you back to whatever it was that would not change anything. So if we have, let's say, 5, we just found out that the identity was 0. What would be a value that would be able to make that equal 0? Well, inverse of this would be we take a negative 5. So the inverse of a plus is going to be a negative of that value. Inverse takes you back to the identity. The identity leaves it the same. It does not change the value that you have. If you wanted to find the inverse of a multiplication, let's say we have 7 times what value is equal to, identity was 1. Well, this would actually be a fraction. This would be 1/7. So that would be the inverse of multiplication. It takes it and puts it as a fraction, or in other words, it takes it and makes it so it would be a division. Let's actually look at the property. Here's words. For any number A, the sum of A and, now we know it's 0, is A, right? Any number added to 0 is A. So in other words, if we wanted to write it out, we can say that A plus 0 is the same thing as 0 plus A because of commutativity, which is equal to A. Does not matter which side we add the 0 onto, it's going to equal A. An example, we already did an example, but here's another example. Let's go with 10 plus 0. That's the same thing as saying 0 plus 10, which is the same thing as saying 10. That is the additive identity. 0 is the additive identity. Additive inverse. If we want the inverse, this is A plus negative A will give us back to the identity. So you just add the opposite of itself. An example of this, we already did an example, but let's do another one. Let's say we have 20. Let's add on a negative 20, and that's going to equal 0, which is our identity. So that's for addition, and we're just going to look at multiplication as well. The multiplicative identity is for any real number a, the product of a, and we already looked at what that was, 1 is a. A times 1 is a. Any number, any real number. So we now know that a times 1 equals to 1 times a, which is equal to a. Okay, whether you multiply 1 on the left-hand side or 1 on the right-hand side, it's always going to equal a. Does not matter. So if we have, let's say, 12 times 1, that's the same thing as saying 1 times 12, which is the same thing as saying 12. Does not change the value. That is our identity. Multiplicative property of 0. For any number a, the product of a and 0 is 0. Right? Anything you multiply by 0 gives you 0. So if we have a times 0, this will equal 0. Example, we could have 7 times 0, that's 0. We could have 0 times 7, also 0. Anything times 0 is 0. You guys need to make sure you know that. Multiplicative inverse. It looks more confusing than what it is. Multiplicative inverse for every number a divided by b. That's a fraction. That's a ratio where a and b are not 0. So if we know that a and b are any number that is not 0, there is exactly one number, b over a, such that the product of a over b and b over a is 1. So in other words, what we're doing, we're going a over b times b over a, that's equal to 1. Or we could put b over a times a over b, that also equals 1, right? By the way that we multiply and divide, how we simplify fractions. Example, if we have 1 over 2, the inverse of 1 over 2 is just 2 over 1, which gives us back to 1. Or we could look at this one. We have 8. Inverse of this would be 1 over 8, because technically this is 8 over 1. Multiplying those out, back to 1. Okay? Inverse takes you back to the identity. Identity is something that does not change the value of the original number. So make sure you know the difference in those. Let's name the property used in each step. So if we have this right here as our expression, let's state what was done. So for this first part, the only thing that changed is this 3 plus 0 turned into just 3. What property was that? That was our identity, right? For addition. So we can say, let's put this plus, and let's say identity. It's our addition identity. It did not change the value that was inside the parentheses. For this second step, only thing that changed was that we multiplied the 1/3 with 3. And that became 1. Well, that right there was an inverse, right? That was our multiplicative inverse. So we're going to say that, and we're going to put inverse. The next step, the only thing that changed is that 7 minus 7 became 0. Well, 0 is the identity of addition and subtraction. So this would be our addition inverse, because it took us back to the identity. For the next step, only thing that changed from this step to this step is that we multiplied 1 times 21. Oh, that's a multiplicative inverse. Actually, it's not the inverse because it stayed the same. I should have said multiplicative identity. For the next step, we did the 0 times 0. That is our multiplicative 0 property. So 0 property. Let's just say the multiplicative 0. For the following step, what they did is they took this 1 and they subtracted it by 21. That's just addition, subtraction. Actually, one other thing we could say about that, 1 minus 21 equals to negative 20. If that equals negative 20, isn't this a substitution? It's taking the value of. We're replacing the 1 minus by 21 by using substitution. So that would be a property that we could use there. Yes, we added, we subtracted, but technically we are substituting. We're taking the place of whatever the 1 minus 21 was. And lastly, this negative 20 plus 0, that right there is going to be, it doesn't change it. So this is the addition identity. Just being able to recognize which property we are using when. Few more things. 2 more properties, and then we're basically done. 2 more properties. We have the commutative property and associative property. We've talked about this before. Commutative property means that the order in which you add, multiply, or multiply numbers does not matter. Okay, so if we could do A plus B, it's the same thing as B plus A. Does not matter the order. So for example, 5 plus 7 equals 7 plus 5. It does not matter the order in which you add. Associative property is how we associate the numbers. We can only add 2 numbers at a time. So if we have, actually I'm going to read the words. The way you group 3 or more numbers when adding or multiplying does not change their sum or product. So for example, if we have, let me do multiplication, A times B times C, you're going to have to group this. Either we group it as A times B times C, or we group it as A times B times C. Does not matter the grouping. You're going to end up with the same result. For example, if we have 2 times 3 times 5, this is going to be the same thing as saying 2 times 3, then times 5. It's going to be the same thing as saying 2 times the 3 times 5. Either way, you end up with the same result. It does not matter which one you multiply first. If you have a bunch of multiplications in a line, do whichever one's easiest. Let's look at some examples of this. Joy is shopping for school supplies. She buys a backpack for $25, notebooks for $10.50, a set of pens for $7.99, and a lunch box for $14.50. Find the total cost of these items. Name the properties used in each step. Okay, so we're literally just going to be adding these up. We have $25. We have the $10.50. We have the $7.99. And we have the $14.50. I know we could go, okay, well, 25 plus 10.5 plus 7.99 plus 14.5. Or we could be a little bit smarter with this. Let's see if we can combine anything to make it easier. For example, let's take this 10.5 and add it to that 14.5. By the way, this would be using our commutative property because we are changing things around. 7.99 plus 10.5 plus 14.5. That's going to make things a lot easier if we do these two first. So we're going to associate these two values before we do anything else. Well, 10.5 plus 14.5 is going to end up to be $25, right? It's going to be $25. So we had 25 plus 7.99 plus 25 more, right? So this was, first thing we did was commutative. Second thing we did was associative, meaning we did this group first. Next thing that we're going to end up doing with this, let's use commutative property again. Let's switch this 25 to be up here. 25 plus 25 plus 799. That's another commutative property. And lastly, well, close to lastly, we're going to associate and do the first two with this one. 25 plus 25 gives us 50. And that is associating it with just those, so associative. And lastly, we can just add those up. So this would be $57.99. So that is the total amount. Okay, so yes, you could plug it into a calculator, but you could also learn these tricks to be able to do it quick without having to need a calculator. Okay, I know that it took me a while because I named what I was doing. We did commutativity, we did associative, we did a commutativity, we associated it again. We named the properties as we went. But if you're able to see these tricks, you don't technically need to pull out the calculator because you are able to get to answers quickly by what you know. Let's look at this one. Evaluate. 1 over 5 times 3 times 5 times 6 times 5. That looks ugly. We don't like to multiply lots and lots of numbers together. You would most likely want to use a calculator. But we can do this without one. Use the properties of numbers. Name the property of each step. So first thing I'm going to do is I'm going to switch a few numbers around. I'm going to switch this to be 1/5 times 5. And I'm going to put another 5. And I'm going to go times by 3 times 6. I'm going to do that. Actually, I'm going to put the 6 and 3 in different order. Let me put 6 times 3. We move things around. Multiplication, we have commutativity, so we can do that. So this is our commutative property again. We can move things around, and it will result in the same thing. 1/5 of 5 is 1. So that was just our associative property. So to get from here to here, that is our associative property. Next step. What we can do is, let's do this 1 times 5. We're again doing the same step. So this would be 5 times 6 times 3. Let's associate again. 6 times 5 is 30. Again, that's associative. And last thing, 3 times 30 is going to be 90. So the rest of that was just the associative property. The way we multiplied really did not matter. We could associate the first two or multiply the last two. It does not matter. We end up with the same result. So main point I wanted you guys to know. Multiplication does not matter the order. You can start from the left or you can start on the right. Does not matter the order. Addition does not matter the order. Do whichever numbers are easiest to be able to get your result.